This time, I'm going to talk about how to make synthetic datasets with Python. What is synthetic data? Synthetic data is data that you can create at any scale, whenever and wherever you need it. Crucially, synthetic data mirrors the balance and the composition of real data, making it ideal for fielding machine learning models. Both real data and the synthetic data are being used in AI models. Let's take a look at this graph. The dark blue stands for real data, and the light blue stands for synthetic data. Now we are here. You can see we are using more real data than the synthetic data. But when we get into 2030, you can see synthetic data will completely overshadow real data in AI models. Then what are the advantages of synthetic data? For data scientists, the real or synthetic nature of data is irrelevant. What really matters are the characteristics and patterns inside the data, its quality, balance, and bias. With synthetic data, we can increase data quality. With synthetic data generation, you get increased confidence in data quality, variety, and balance. Also, when you train your AI model, you need a lot of data. Many data scientists supplement their real-world records with synthetic data, rapidly scaling up existing data. Finally, synthetic data is refreshingly easy to generate. With synthetic data, you can control how the resulting data is structured, formatted, and labeled. Usually, businesses generate synthetic data based on the real data. When you use real data, you will have a privacy concern. So there are two parts in this generation system. First, you have privacy assurance services, and then you have data synthesis services. First, usually businesses will feed the real data to privacy assurance, and then after privacy assurance, it will start this synthesis process. After this synthetic data was generated, and it will pass this utility assessment, and then go back to this synthesis process. And eventually, it will generate report and generate synthesis report. There are many ways to generate synthetic data. One way to generate synthetic data is using Python. If you use Python, there are three packages you can use. Scikit-learn is one of the most widely used Python libraries for machine learning tasks, and it can also be used to generate synthetic data. Another package is SymPy, and the third one is PyDBGen. All of them can be used to generate synthetic data. In this video, I'm going to show you how to use Scikit-learn to generate synthetic data. Let's go to Python, see how it works. In order to generate synthetic data with the Scikit-learn package, you need to import make classification function first. Now, let's generate 1000 data point with 2 features, no redundant, and each class will only have 1 cluster, and they will have equal weight. That's why the weight here is 0.5. Let's generate some data point. This is our data. Now, let's draw a graph in order to see it visually. You can see we will have 2 classes of data. One is orange one, another one is blue one. They have some overlap, and within this orange class, there are some blue dots here. You might wonder why we use this random state here. The random state is being used in order to make the data output consistent. If we comment out this line and we rerun this program, rerun it again, rerun it again, you can see every time it gives us different data output. And then when you train your model, if you want to compare your output with different run, it's hard to compare the data output because the data inputs will change every time. If we put this random state back, you run your program, you run it again, you run it again, it will give you consistent result. So you have same data input every time. That's why we use this random state variable here. And now let's add some noise. You can see after we added some noise here, there are more blue dots within these orange data points. And similarly, within these blue data points, there are more orange data points. And when you want to add noise, you will put flip y here as 0.25. If you put 0.0, you rerun the program. You can see the noise will be removed. And if you put 0.5, there are more noise here. So when you want to add noise, you want to use this flip y parameter. Now, if we want assign different weight, this is weight 0.95. That means your data points with the different classes are not equally weighted. Obviously, this blue data points has more weight. It's 95%. And this one, the orange class, will have 5%. And similarly, if you assign the weights to 5% to the blue data points, you will get fewer data points for the blue class and 95% for the orange data points. Now you can see those two classes are overlapped. What can you do if you want to separate them? In that case, you will use this parameter, class sep. You set to a higher number, for example 5. If you run your program, you can see the two classes are separated. If you put a lower number, let's say 3, you rerun it, it's getting closer. And then if you put 1, you see it has more overlap here. So when you want to separate or overlap your different data classes, you use class sep parameter. This is my brief introduction about synthetic data and how to make synthetic data sets with Python. Please provide your comments and subscribe to my YouTube channel. Thank you so much for watching.